Now see in this question, a 10 kg satellite circles Earth once every 2 hours in an orbit having radius of 8000 kilometer. So we have got radius of the orbit is 8000 kilometer, that is 8000 into 1000 meter. We can write 8 into 10 raised to power 6 kilometers. Assuming that Bohr's angular momentum postulates applies to satellite just as it does to an electron in the hydrogen atom. Find the quantum number of the orbit of satellite. So we have to calculate quantum number of the orbit of satellites. For that quantum number, that we need to calculate angular momentum, and for angular momentum we need to calculate velocity. So first, how do we calculate velocity here? So we can apply this formula, v is equal to 2 pi r upon t, circumference divided by total time taken to complete one revolution, that is 2 into 3.14 into 8 into 10 raised to power 6 divided by 2 into 60 into 60. When we solve this, we will be getting, that is 2 hours I have converted into seconds. So we will be getting v is equal to 7 into 10 raised to power 3 meter per second. So this is the speed of the satellite in its orbit. So we have calculated speed. So we can write here now v is equal to 7 into 10 raised to power 3 meter per second. Now we can calculate number of the orbits. Here L is equal to mvr is equal to nh upon 2 pi. We have to calculate here n. So we can write n is equal to mvr into 2 pi divided by nh divided by h. We can put all the values over here in this case. So when we place this value, we will be getting 10 into 7 into 10 raised to power 3 into 8 into 10 raised to power 6, 2 into 3.14 divided by 6.63 into 10 raised to power minus 34. We can solve this. So when we solve this, we will be getting here n is equal to 5.3 into 10 raised to power 45. So this is the quantum number we are getting in case of this satellite.